Differential mode current, common mode current, EMC technology essentials, high current flows. At low frequencies below 50 kHz, the return current typically follows the path of least resistance. At high frequencies above 50 kHz, the return current typically follows the path of minimal impedance. Please note that these two concepts are not the same. The path of least resistance depends on the material properties of the conductor in the return path and the distance from the power source to the load. That is, the return current flows directly back to the power source. The path with the least impedance depends on the inductive effect and capacitive effect between the printed line and the return path. This will cause the return current to flow directly beneath the signal or power printed line. The reason for this phenomenon is that at higher frequencies, the self-inductance of the signal current path is the smallest, and the stored magnetic field energy and path impedance are also the smallest. This usually minimizes the physical space, or loop area, between the output current and the return current. Can the above concept be more easily understood by observing how the transformer works? As shown in the figure, when alternating current AC or high-frequency current flows through one of the windings of a transformer, by coupling with the magnetic field of the adjacent winding, a current in the opposite direction will be generated on the other winding. When current passes through a conductor or a printed circuit layer, their working principle is the same as that when current flows through a printed circuit line. Next, consider a concept. What kind of current is usually referred to as differential mode DM current or differential current? They are the signal currents or power supply currents from the power source to the load and then back from the load to the power source. The closer these two paths are to each other, the smaller the self-induced magnetic field they generate. This will reduce the coupling with other wires, printed lines, or circuits. A large loop is created when a power supply, signal printed line, or wire is forced away from its return path. As shown in the figure, problems will arise in this situation. The larger the loop, the greater the radiated magnetic field it generates. Conversely, this is also more likely to receive magnetic fields generated by other magnetic field sources, which will introduce interference into these circuits. Fortunately, the return layer or reference layer is usually used and is often mistakenly called the ground layer. The printed lines on the return layer or reference layer will have a direct inductive coupling with the return path beneath them. Printed lines with local coupled return paths can minimize the closed loop area between them and the return paths. This minimizes the emissions generated by the printing line, and to minimize the sensitivity of the circuit to external interference. However, when routing the PCB, if there are several layers between the signal current path and the return current path, or if there are islands or notches on the return layer or reference layer, then the reference layer will lose all its advantages. The paths through which common mode CM current and differential mode DM current flow are different. The difference of common mode current lies in that they flow in the same direction along the signal circuit or return path. Their values are usually also very small, at the microampere level. A good way to understand differential mode current and common mode current is, each differential mode current digital signal requires a dedicated return path to function. However, common mode current only requires a return path to be provided shared. If no return path is provided for the common mode signal, then it will search for it by itself, which is very likely to form a large closed loop area. This will generate stronger radiation emissions. Other methods for generating common mode current include the use of a voltage source. It may form capacitive coupling with the casing, such as through the heatsink of the power supply. The voltage between the switching device and the housing can generate a common mode current throughout the circuit. In this case, a connection must be found on the housing to allow the common mode current to flow back to the power supply. For isolated power supplies that have no AC connection with the casing, this will cause all power sources and interconnection cables to emit radiation. Efforts should be made to return this electrical energy to the casing and then to the power source. If there are overlooked grooves or gaps on the return layer that force the return current to flow through a longer path, or if the impedance matching between the power supply or load of the high-frequency signal circuit is poor and overlooked, then common mode current will also be generated. Alright, that's all for today's content. See you next time.